For me, what we did, if you recall, our last field exercise was to do what? Alright. And today's exercise is going to be a little bit like that, using some of the same tools and related techniques, but not quite the same thing. We're going to focus a little bit on so-called icon sites or gravity features or what have you. So the idea with an icon site is simply that in a wilderness area, not all grid points on the map are the same. We've got some flat areas, we got some wet areas, we got some dry areas, we got some steep areas, we got some flat areas, and you and I as human beings think about those qualities, we kind of synthesize them together according to our goals for moving through that space and being there for a time. And so we want to start thinking about a map of a wilderness area in terms of, okay, so how would my key wildlife species need for this particular chunk of a map, which may or may not have boundaries on it, according to ecological transition zones and boundaries, like watershed edges, mountain ridges, water courses, stuff like that. The map might have a wilderness area that looks like a big square, and that's difficult to manage in an ecologically functional way when you're a forestry and wildlife and wilderness specific to those professional. Okay, so let's think about Thompson Woods here for just a sec, using this as a proxy for a wilderness area, a very, very small one. We have several acres, or hectares, and we got a pretty heterogeneous setup throughout. So when I say heterogeneous, I'm talking about stuff like this patch right here, even just visibly looks pretty different than the patch right behind it. You can see a clear transition, yeah? Okay, so let's use these different patches as part of the ecosystem of this area to represent different ecosystems in a wilderness area. Typically, wilderness areas are big enough that they'll encompass several different kinds of ecosystems as they go. So riverine or riparian systems, riparian being strips of bank on either side, low-lying, typically saturated or near saturated soils except for ephemeral streams, and so on and so forth. And then we got, well, a lot of wilderness areas tend to be the core mountain habitat, because that's how we tend to think of rugged places being more wild. Because all the flat places we're using for rangeland, mining, strip malls, and subdivisions, and so forth. Tracking with me so far? All right, cool. So, grab your riding utensils and let's kind of step on into our miniature wilderness area here. Leave some of these items behind. We'll again stay pretty close, kind of within eye shot of this area. Technical term for that being the same view shed, so we can see these 2 points from each other, where we'll be in the woods, and we'll be dropping stuff right here. Okay. Keep an eye out for poison ivy if you got shorts on. This'll do. All right, so when motile, meaning moving instead of stationary or anchored wildlife, when motile wildlife and when human beings look out across a landscape like this, we're making an unconscious, in most cases, decision about something called pathing and travel cost analysis, or least cost surface analysis. Because when we get to a wilderness area, we don't just want to stand at the trailhead with a parking lot looking fat, dumb, and happy. We want to get into the wilderness area and check out that mountain peak, or ford that river or raging stream with snowmelt, or carefully avoid the grizzly bear you can see down in the valley browsing for soapberries and so forth. So, travel cost analysis, or least cost path surfacing, is something that we all do anyway. So as a wilderness manager, we want to understand that people walking across, let me tip the camera down so you can see this, people walking across open terrain or traveling cross-country, as we say in the industry, I am incrementing a counter for how many times these particular individual, in this case plant organisms, and some detritivore organisms like insects, beetles, earthworms, that kind of thing, how many times each one of those has been stepped on. And each of these species has a characteristic range in which it has a tolerance for how many times it can get stepped on before it goes pop, or it breaks. Okay? So, if we step on something that's woody, I'll use a dead stick as an example, to the point that we hear it pop, that's ecologically equivalent to breaking a bone in a human being. We can recover from that, but we can't have that happening all the time, or our bodies will lose the resources that we're spending to recuperate from that and not be able to get them back. And then eventually bodily systems and functions collapse. So, we want to understand that this least cost travel surface is not just a theoretical surface, it's a literal physical thing. And different parts of this surface are going to look more attractive and less attractive for us to walk on. So, if we say that our trailhead is that rock where we started, we dropped our packs, and our ending point, our mountaintop vista, our summit, or our campsite partway up the ridge. And typically halfway up the ridge is better than at the top or at the bottom for a bunch of good reasons. We'll get into those. How did you get from there to where you're standing now? Did we all walk single file? No. We took probably a dozen different paths, and there are about a dozen of us here. So this least cost travel surface is fairly similar along a couple of lanes here. And we kind of spread out through the trees, and we take paths that kind of braid or run parallel to each other and then come back together. When we have a bunch of people doing this, like near a trailhead and like near campsites, like near icon sites like a waterfall or a mountain summit or whatever, people tend to hit that spot and then spread out, like individual burning chunks of magnesium in a firework. And what that does is it increments the number of times that each of those spots next to the icon site or near to it have been trampled on. And for a grassoid, out there in a sunny fields, well watered, the soil is supportive, well aerated, meaning not trampled and crunched down. So like water can infiltrate, nutrients can migrate upward out of the weathering reactions of the parent bedrock, and so on. We can walk over that 1,000 times a day in peak season, and the grass will lay prostrate and then spring back up with a little bit of water, maybe some morning dew the next day. That's pretty good. That's why we put grass or turf on things like playing surfaces in sports. It can handle thousands of tramples over a season. Something like forest forbs, like we don't really have a lot around here, but things like ferns that don't even have woody structures or rigid cellulosic structures, that just have sort of green growth that's seasonal. Sometimes their trample limit is 0. You step on it once, and that's it for that plant that season. It's done. So, as wilderness managers, you want to start thinking about what are some ecologically resistant to trampling impact ways to get everybody from point A to point B, because we know everybody wants to get to the mountain summit, or at least most people do. And everybody's going to need a campsite overnight, because wilderness is supposed to be able to easily absorb a pack trip of 2 weeks in length. And if a good experienced backpacker can cover 20 to 30 miles per day times 2 weeks, that's a big area. So we want to, in places where the use is really low, disperse use and let every trampling be totally randomized and be a maximum of 1, because no paths form. Everybody's so spread out that we don't even have a chance to make paths as we're walking through. And everywhere else where we can't do that, we can't get away with making sure that only one person's ever going to walk in one spot, we need to concentrate that use into areas that are going to get pretty completely trampled. We call those trails. We call them campsites. Okay? Cool. So, let's use this tree as our starting point. And there's another big field stone like the one where we started at, kind of right up and over there. And we can get to that a million different ways, right? So, let's evaluate some of those different ways. Okay? Start here. And generally, face towards where you're going. This is the process of site-based trail layout, okay? Start where you're going to start, or start where you're going to finish. And then don't walk straight towards it. You want to do anything but that, because that is, in most people's minds, the unconscious or mindless least path surface. It's the fewest calories, the least sweat equity we got to put in to get from here to over there. All right, so try it out. Let's walk through the woods a little bit. Okay, here we go. So this is an exercise we're going to be doing at headquarters when you're a wilderness ranger in a GIS or a mapping software, to get a general idea of how can we kind of wind our way up this mountain instead of going straight up it. And then at some point we got to get out there and do the thing and cut in a trail if a trail is the right tool to solve this. Otherwise we're saying this whole area is your not trail, and go anywhere you want, but wherever you see a trail, don't walk there, because that means the trampling is overwhelming this ecosystem's local capacity to heal from what you are doing to it. Okay? Cool. All right, let's go find that fieldstone. Here we go. As you are walking along, I want you to do the following things. First, put together a basic sketch map of the area. X marks the spot for where we start. Okay? Sketch in a very basic scale bar. What kind of a size of an area or compartment are we talking about? Doesn't have to be perfect or precise. This is just a sketch map. Okay? If you've never done this before, we're just going to demystify this process. This is just taking notes spatially. Okay? And then as you walk along, once you've got your map sort of baseline started, add a few landmarks. That edge of the forested area here is a landmark. This is a landmark. Geographers would call this a POI, or a point of interest. The kind of thing that will be marked on a topographic map specifically. Things like cemeteries, water confluences, and old farm roads, jeep roads, dirt roads, wagon paths. Okay? All of this is just approximate. While you're moving along, kind of plot out your path as you go with a series of points. And then later we'll connect the dots and you'll have what's called a polyline feature. When we're using a GPS, like that big yellow thing over there, it'll record that part for us automatically, and we can attach a bunch of data to each of those points. Like, am I walking up a cliff right now? I probably want to know that when I'm making a map of this and planning out where I'm going to put my wilderness trail. Okay? So I'm going to walk generally in the direction of our destination so you can see where it is. What I don't want you to do is follow in my footsteps, because that's going to form a path. You can already see some places where the vegetation is trampled down just from the last few minutes. Okay? Wander around. If you go like 90 degrees or even like 120 degrees off of our general destination, that's fine. That's completely fine. You guys ever been on a twisty, windy trail before? That's what that looks like. As you drop a point on your map, as you're moving along, note for each one of those points, am I going straight up slope? Am I kind of 45 diagonal off of that? Am I perpendicular to the landform slope right here? This is very important. So make a note of that for each one of these points that you drop on your map. Alright, cool. And as you get closer, kind of drop your last point right about here. We'll consider this our mountain summit, if you want to look at it that way. Or a campsite, or backcountry latrine, or privy, as they're called. Whatever.
What were you saying to mark with all of our points?
So for each point, you want to mark, am I going straight uphill? Am I going perpendicular to that, so running along the contour line?
Okay, gotcha.
Is it somewhere in between, like 45 degrees off? Am I just barely off the hill slope? An easy way to do that is like a single arrow for what is directly uphill from this point on the map, and then what direction am I facing at that point.
Okay.
And hopefully they're not exactly the same, but you know, whatever.
Right. And we're just doing that with the actual terrain here?
Just where you drop a point. So in a GIS, we get that, what's called the aspect, or the hill facing, for every point on the entire raster grid, but we don't care about the entire raster grid because the trail erosion is only going to happen where we're forming trails.
Right.
So, great question. All right, for those of you just coming in, put your last point, you don't have to like walk right here, but put your last point conceptually right where I'm standing. This is our mountain peak or our campsite, what have you. Okay, and for each of those points that you marked on the map, if you recorded or had a chance to record, am I going straight up slope? Am I just slightly off the hill slope? Am I slabbing or staying iso-elevational or contouring, following contour lines on the topo map, meaning I'm perpendicular to the hill slope at this spot, in which case the arrow pointing up slope would be this way, and I'm facing this other direction. Arrow pointing uphill, I'm facing straight uphill, so the arrows are parallel to each other for that point. Okay. So each one of these points might look like a little clock face, with a little arrow at the end of each hand. Cool? All right, everybody got what we did so far? All right, flip around your map so I can see them. Show me what you got. All right, looks good. We got a little meander there. All right, Taryn, thank you. Looks good. Cool. Looks good. Very good. All right. Got a couple of points of interest. Good. Okay. Looks good. Show me what you got.
Getting there.
Cool. Yeah, it'll come together. All right, so now kind of zooming out for a sec from the individual points that you chose on your pathing exercise, figuring out some pathfinding way to get from point A to point B. Kind of zoom out from that a little bit and turn back across the general area that you traversed and look at what's the general, what direction is the overall landform slope between where we started, that other fieldstone, and right here. Yeah, it's going down. So like if, one way to think of it is if it's raining, and a drop of water goes through my head, hits the ground right at my feet, broadly speaking, what direction is it going to flow? Down along the path, yeah? And if it falls right over here, it's going to go down that way. And if it falls over here, it's going to flow towards us. So this is a sub-peak or prominence. Okay. So both at a micro kind of step-by-step level and an overall landform level, we want to always be thinking in terms of, as the research has demonstrated over and over and over for trail design, am I going upslope, which is the same thing ecologically as going straight downslope, because the water doesn't care about your trail, it's just going to flow downhill from that spot. So locally, if this isn't paved, this is rough forest floor, and we start walking it in, and it gets compacted from a whole bunch of passes, millions of passes on busy trails, it's going to start to compact down and form a trough, and then that's a gully for erosion. So it's a small rill, and then it's a big rill, and then it's a gully, and then it's a stream bed, literally. So in places like Great Smoky Mountains National Park, where we have a lot of precipitation, or in places like the Hawaiian Islands, which are surrounded by warm Pacific waters, and we get a couple of 100 inches of precip each year instead of a couple of dozen inches on a normal year around here. So like an order of magnitude more. This is a non-trivial thing. If we put in a trail that, even if it's wandering a little bit, but generally kind of goes right down slope or real close to right down slope, we're hosed. Or at least our trail is hosed by rainwater and it's going to get scooped out and scooped out and scooped out over and over again every time there's a rain event. So take a look at your map. We'll start heading back so we can keep it on our backs. Take a look at your map and just real rough estimate in your own head. Try and guess, okay, half of the time my trail is basically running straight up the slope. That half of the trail, even if it's in multiple separate segments, are going to be stream beds when it's raining. And the other half of the time, when I'm kind of going sideways or perpendicular to the way that the hill is trying to flow water, water's going to flow across that trail and maybe hit the trail and immediately flow off, or hit the ground above the trail, hit the trail and then immediately flow off. And the trail surface is going to stay where it is instead of getting washed away. So a sustainable trail is going to be pretty long because it's not going straight to its destination, and we want to have lots of elevation and lots of slope, therefore, because slope helps us get water off of the trail. If we're running trails in very flat areas, there's nowhere for that water to drain except for right where your feet go, and that's the worst kind of trail. All right, let's start walking on back. Okay, so we have some kind of introductory but rapidly developing understanding of this is a non-trivial problem to figure out how to get our visitors, our recreationists, our users, our human wildlife species from point A to point B, because we're going to look at this landscape very differently than most wildlife species. Wildlife species, by and large, except for a few highly mobile and predatory birds, for example, they're not going to see things like cliff edges and peaks at all the same way that we are, right? So a cliff edge is very exposed. If you're a prey animal, that is prime getting hunted territory. And a human might see a cliff edge and go, I think I see some pretty big stable boulders up there. Let's get up there and top rope down. Sounds pretty good to me. All right, so we want to understand human behavioral preferences as well as those of wildlife, and understand that if you're a hoofed wildlife species, you really don't like contouring, because your hoof is shaped like a hypodermic needle, which is just an open cylinder or tube with a long diagonal cut, so it goes right into stuff like your veins, so you can donate blood, or recovering convalescent plasma if you're COVID-19 survivor, whatever. Horse hooves, for example, are shaped much the same way, except flipped over, so that that hoof can dig into the ground and get some purchase or traction. And the way that works kind of biomechanically is that works in and pushing off and getting straight up a slope and forming wildlife trails straight up and down slopes. See where I'm going with that? and works really badly at going sideways across that slope. But we just got finished doing an exercise where we're realizing, okay, for humans, because we're modifying the soil surface and we're removing vegetation, we're trampling it, we're cutting it out on purpose, that's totally the opposite. So where we have a cross-country dispersed use setup, where folks are generally staying away from trails, a very common temptation for a human in that case for hooking up the least cost travel surface, at least for the next couple of steps, is to use a wildlife trail. And in a lot of cases, those wildlife trails are not what you want, okay? So the only place, the exception that proves the rule, the one spot where we want to go straight up the slope and straight down the slope, or where we're crossing running water. So if you've ever been backpacking and had to ford a stream, we don't want to run the trail along that stream, because then it becomes just a parallel stream bed when the stream is flooding or raining. We want to approach that crossing because we're generally contouring as much as we can, not going straight up and down slope, but perpendicular to that, or nearly perpendicular, zigzagging back and forth, switch backing up or down. So we want to hit the stream bed crosswise, so gently climbing, gently descending. Hit that perfectly crosswise, in and out of that stream bed as fast as possible, and then gently climbing or gently descending beyond that. Sound good? Okay. That gives us the least exposure to sections of trail, and the more we turn it to align with that stream bed, the more it is the stream bed. Okay, so horse fordings, for example, have to be perpendicular because they got to go straight up out that slope, especially where it's wet and slick, and horse trails are typically eroded, so they'll collect loose stones called cobbles. You can trip on those and break the horse's leg, and that's real bad because they're under such tension. It's near impossible to fix a horse with a broken leg, and so forth. Sound good? All right, any questions or any clarity about this stuff so far? It's okay if this is a new concept to you and you're still kind of piecing it together in your head. So far, so good? All right, we got 7 minutes. Let's do one more quick pathing from here to there. See if this one's any different than your first one, okay? Maybe it was perfect the first time, but maybe because we're just trying this stuff out, we're practicing, and it's just kind of for funsies so far, maybe we can see some change between path 1 and 2, okay? So typically the second draft of a path is longer. There's more switchbacking and zigzagging and moving around control points like big trees, which we can use to keep people on trail instead of shortcutting those switchbacks where they get close to each other. All right, give it a shot. 7 minutes to get like not even 100 meters. Good luck. And I know I'm kind of yelling. I'm just trying to get picked up by the microphone here.
Good.
What's up?
So we're just essentially talking about like the most ecologically friendly way to travel through here, right?
Yeah, because the most ecologically friendly way is going to have the least erosion, which means the least blown out trails, which means less maintenance and cost, nicer to walk on.
Yeah.
You can explore more of the landscape instead of just getting people real quickly there, and then they have
Oh, I get all that.
too
I
much
just wanted
time
to
to
make
get
sure I
trouble.
was approaching this from the correct perspective.
Yep, for sure. And as it turns out, the more it wiggles around, the more people like it.
Yeah.
So you're even scoring a win that way.
Well, so I mean, like, I know you know that on the Appalachian Trail, switchbacks are everywhere.
Yep.
If you've been on the long trail, they built that trail back in like the 1910s, and so they do it the traditional way, which is just straight up and straight down,
Yeah.
and so you end up walking down a lot of flowing water when it rains, you know?
Absolutely it is. And the AT in Vermont runs along the long trail for a little bit.
About 150 miles, yeah?
Yeah, it's got that roller coaster section, which is just up and down, up and down.
Yeah.
A bunch of those 300 peaks along the trail, and then it turns like 90 degrees to the right. And it's up and down, but it's crossing mountain lines instead of going along a ridge, which is super erosive.
Yeah.
So, yeah, we get it both ways, but as every year they relocate short sections of the AT, and it tends to grow longer. It was 2,174 miles when I did it in 2004, and it's grown a lot since then.
2191 when I did it a couple years ago.
Yeah, like that's a lot of extra trail.
Yeah, it's getting quite a bit longer.
Yeah. Don't be afraid to do it like in the song. Stop, wiggle, wiggle, wiggle. Move back and forth on the landscape all over the place. Go check out something that looks interesting. Your visitors probably want to do that anyway. Bring it by a huge tree. All right, we got about 1 minute. Go ahead and finish at amplified speed, and then we'll finish up back by where we started. Yeah, so for example, here's a point on your trail, just random spot. If this is where we started, this sort of plus sign, and this is where we're ending up, our mountain peak, the slope is generally going to go increase from where we started to where we finished. So if you think about it, for each point on this trail, if this is a uniformly sort of conic peak, just everything moves up to here, and this arrow points straight at the peak, this arrow points straight at the peak. This arrow is also pointing straight at the peak, but it's a different direction than the others.
Okay.
And so what we're looking at, what I'm getting at here is, what's the angle between the landform slope, landform, and trail slope.
Okay, so like 70 or...
Oh, that's probably 70 degrees. Good estimate, 75.
Okay, cool.
And as it turns out, 75 degrees is going to be like running about as hard as we can. 75 degrees off of the landform slope is about as close as we want to get to the landform slope. Anything smaller than 75 degrees for that trail slope alignment angle, really erosive. Because just like COVID-19 spreading rates, Erosion is an exponential, self-reinforcing process. All right, we got to finish. So let's start walking back, and I'll take you through how to finish this up. So now you've got a map, or maybe a couple of different maps. If you did them all combined or separately, that's fine. And you got a bunch of points, and you got a bunch of trail slope alignment estimates for each of those points on each of your 2 trails. The next step is to head home and find a ruler or a piece of string and measure the length of each of these 2 trails. Okay? And then count how many of your points are bigger than a 75-degree angle, to be between 0 and 90 degrees, because the trail runs forward and backwards. So when you get bigger than 90 degrees, you just sort of wrap it around the other way. And give me a tally for each of those points, and you don't have to do every single centimeter along your map, but half a dozen points. Give me the proportion of those points that is more than 75 degrees off of the hill slope or the hill's direction, or facing or aspect, all the same thing. And how many are smaller than 75 degrees? It's not a showstopper problem to have even a couple of spots that are like a few degrees off of the slope. Sometimes you just gotta run straight up the slope. There's one little break in a cliff face, maybe. And you gotta get everybody to the other side, so that's where you do it. And you take a bunch of different techniques to armor up the trail in that spot. Because everywhere else, where your trail is running more than 75 degrees off of where the landform is facing, that trail's gonna take care of itself. Forever. All right? Once you measure the length of your 2 trails, and write that number somewhere on each map, and tally up the proportion of points that are more or less than 75 degrees off of the landform, take a good clear cell phone or digital camera picture and email it to me. Okay? And I'll have your name by your email address and be able to give you credit for your hard work. And folks who are doing this at home or separately, you're gonna do the same thing. Sound good? All right, I'm keeping you long now, so if you gotta go, go. If you are wearing shorts and you cross poison ivy, you got about 4 hours before that urushiol binds to your skin. Soap and water. Don't take a hot shower, that'll open your pores and let it in. Take a nice cool shower, that's gonna feel better on a day like today anyway. Okay? Cool. All right.
The trail slope, what were you talking about with the ratios and stuff? Can you just go over that again? I didn't really catch that.
Yeah, sure. All right, so we'll try and get this on camera too. All right, so
Yeah,
diagram it out for you. How do you like that? All right, so we got, where do we start? Here's our start point. Here's our finish point. And we said that generally, the trail or the landform kind of monotonically increases in elevation, so it goes up without going back down between here and here. So the slope is overall basically like this. So for each spot that you choose on the trail, just draw a dot and draw an arrow pointing to the point. And draw a second arrow. Really, you just got to draw the head of the arrow because you're drawing it in the direction that the trail is running at that spot. And what we're interested in is what's the angle between those two. That's the trail slope, or landform slope, alignment angle, or TSA. It's between 0 degrees when we're running straight at it, and it can be as high as 90 degrees when you are running. There's a point that is probably very flat on the trail because it's about perpendicular to the goal. Mm-hmm. Okay?
Okay.
So tally up what, a half dozen or a dozen? Give me the proportion between them.
Cool. And then it's just on
You said just get the string, and so the length, you're just using that as
You got it.
the point cell formula. Basically.
Yeah, it's a little bit easier than like trying to walk a ruler along it. Yeah. And in a GIS, we'd have the map tallied up for us, but this works too. It's nice and fast. Okay.